Good afternoon, all my dear students. How are you all? I hope you are taking care of yourself as well as of your family. Today, I brought in front of you all the separation method, crystallization and the recrystallization. Few points of this method we have discussed in the first semester. So we should go for more points in these methods in this lecture. In this lecture, we are going to understand the introduction of the crystallization, its definition, the crystallization process, various types of the crystallization, the applications of the crystallization, recrystallization method, and what is the major difference between crystallization and the recrystallization. What is the learning outcome of this lecture or the topic? The students are able to understand about the crystallization method of the separation and purification, how it takes place, its process, its various types and applications. Recrystallization method and the difference between both the method. So what is crystallization? It is the formation of the solid particles within a homogeneous phase. It is the separation as well as the purification technique. The crystallization is, we can say, it is the separation as well as purification. It is the formation of solid particles in a homogeneous phase. For the crystallization to occur, the solution must be in the beginning stage of the supersaturated solution, or we can say it is the saturated solution. And we should know the difference between the saturated, supersaturated solutions. Supersaturation means that at a given temperature, the actual solute concentration exceeds the saturated concentration. Saturated concentration is the maximum amount of the solute in the solvent. So that maximum amount of the solute, that stage is called saturated, and if that concentration exceeds, that stage is called supersaturation. Means the beginning of the supersaturation or a saturated solution, it is occurred for the crystallization. On adding a solid substance in a liquid and continuously go on stirring it, the solid always dissolved in the fluid. But when added more and more solid to the liquid, a point comes after which no more solid dissolve in the liquid. Understood? So this point is called saturation point. And that type of the fluid is called saturated solution. So you have your difference between supersaturated and the saturated solution. You can say after this point, the supersaturated stage begins out, and this is only the point or the stage which is useful for our crystallization. Crystallization process consists of these several steps. So let's see the various steps involved in the process and how the crystallization occur. So the step 1, in which we have taken the impure solid which is dissolved in the appropriate solvent in a beaker, and there is a stirrer. We go for stirring the solution, and the addition of the solid in the solvent goes on until the saturated solution is formed at the room temperature. Then this solution goes in the step 2, where we have taken a china dish. We go for transferring the solution in the china dish, and there is a burner at the bottom. We go for starting the solution to heat, and the addition of the solid go for adding in this china dish until a hot saturated solution is formed. So that is the step 2. We have to make a hot saturated solution. Then the step 3 involve that this china dish is allowed to cool. So when you go for cooling down the solution, then you are able to see here on the walls of the china dish, the crystals begin to form. So when the complete crystallization takes place in the step 3, then the last step is we go for having the crystals in the filter paper sheet for drying. So we have the various crystals, we go for taking it. And these crystals are pure crystals. So one type of a process we have understood of the crystallization. Here the example of the crystallization process in the various steps given for the separation or the reaction method. When we have done some reactions and we are going to separate our crystals, so that involve the step 1. The solution of the reaction, goes on heating in an open container. Then it go for the step 2 that involve the evaporation method, so that whatever the solvent molecules are there, it goes for evaporating. Then the step 3, we go for cooling out the crystals, so it starts accumulating on the surface of the solution. This step 4 it goes for collecting out the crystals and dried it up as per our requirement. The step 5, the undissolved solids. In the liquid we are having, if some undissolved solids remain, it goes for separating out the process of filtration. Then the step 6, if we go for having how much size of the crystals we have produced, it depends always on the cooling rate. So rapid cooling affect the size of the crystals. We should go for slowly cooling so that appropriate size of the crystal we get. In the step 7, the large crystals you are formed at the slow cooling rates. Now we go for the various types of the crystallization method depending on the major process involved. The first category of the crystallization is evaporative crystallization. The second crystallization is cooling crystallization. The third crystallization is the precipitation, which is also called reactive crystallization, and the fourth one is fractional crystallization process. The choice of the method of the selection of the type of the crystallization we can select the method according to the properties of the compound to be crystallized. Understood? So we can select any kind of the crystallization method according to the compound we have to crystallize it. So let's start the first crystallization type, that is evaporative crystallization. The major thing is in the process involve the evaporation of the solvent. So in that case, we go for forming the vapor and a suspension of the crystals. Understood? So allowing the solution to evaporate and making it a hot saturated solution. So evaporation causes the saturation and the concentration of the impurities left behind will become so high that it influences the crystallization or the product purity. So the main thing here, we are going to heat out the solution and make it saturated, and the vapor goes on producing, and that is responsible for the crystallization. The next type of the crystallization is cooling crystallization. It is very attractive type of the crystallization. It occurs when the solubility of the product goes on increasing with the increase in the temperature. So when such kind of the samples are there which goes on increasing its solubility with the increase in temperature, where we cannot use the evaporative crystallization. So in these cases, we should go for cooling crystallization. Cooling is the main process involved. So the cooling takes place, the liquid is cooled to a temperature below the equilibrium solubility. So we have to cool such kind of solutions with that temperature below its equilibrium solubility, and that cooling should be done very carefully, because we have to select that temperature of the equilibrium solubility to prevent the accumulation of the crystals. Otherwise, if we go for cooling directly, maybe the good crystals are not formed in the process. The third type of the crystallization is precipitation, or that can also be said as a reactive crystallization. So what type of this crystallization is? In this, the solid phase is formed due to the reaction. As I have taken one example in the crystallization process also, step by step, where the reaction taking place and you are obtaining the crystal from the reaction. So the reactions can be acid base reactions, which is having the B to form salt and water, acid base reactions. These reactions are very fast. Understood? And very highly it goes for exothermic reactions. Heat is released in these case, which goes for easily go for precipitation and forming the crystals. So ionic reactions and acid-base reactions, on the basis of the reactions, it goes for the crystallization, because some of the reactions like ionic reactions and acid-base reactions, it convert directly, it precipitate out and directly form the crystals. The last type of the crystallization is fractional crystallization. What is fractional crystallization? It is used to describe a process where repeated crystallization steps are used to increase the purity of the product or to increase the yield. If we want more yield, more purity, the crystallization step should be repeated. It go for repetition. And if we go for more and more crystallization steps in the repeated form, we have more yield and more purity. The main application of the process, which is go for the fractional crystallization, it is metal refining. We have to go for removing the impurities continuously. So metal should be refined here. So the crystallization goes for having the repetitive process used in such application. Oil and gas, we do not perform only one step of the crystallization. We have to repeat the crystallization process many times. That is the fractional crystallization. So in the first stage, it goes for the separation from the liquid. The various devices also used, because in a large scale it is used. So various devices like filters, centrifuges, or the wash column, it should be go for again heated at the high concentration. and higher operating temperature, after resuspending the crystals, may be allowed to grow. And the solvent we have to use in such cases or in such of the method, it should be have appropriate characteristics. Means the solvent which we have to use in such kind of method, it should be appropriate to your sample, to your compound which is going to separate out in the crystals. Now we move towards the application of the crystallization. As you understand that this is the method of the separation and the purification. So it is used for the purification of the seawater. Seawater containing various impurities. The main impurity is NaCl, that is 3.5% of the NaCl is there in the seawater, which is highly impure. For purification of the seawater, it is used, as well as it is used in the various purification of the drugs in the pharmaceutical industry, the separation of the various crystal compounds like alum crystals from the impure samples, as well as you know, the copper sulfate crystals from the impure copper sulfate solid. In the food industry, it is used to separate the solid phase from the liquid phase. For example, the sugar, glucose, lactose, citric acid, and salt. So these are to be having the recovery of such kind of crystalline products in the food industry. It is also used. Now the next method is the recrystallization. What is this method? It is a technique used for the purification of the solid compound. It is not a separation method, it is a purification method. The solids tend to be more soluble in the hot liquids than in the cold liquids. So there is a condition here that whatever the solution you want to recrystallize, it should be more soluble in hot liquids than in cold liquids for the recrystallization. During the recrystallization, and the impure solid is dissolved in the hot liquid. If it is soluble in the hot liquid, it is to be dissolved in the hot liquid until the solution is saturated. Again, we have to add the solid compound in the impure solid compound in a solvent, and then again it go for forming the saturated solution and allowed to cool, and then it is after the cooling it form the crystals, pure crystals we get, pure. The crystals are then removed from the solution by the filtration method. It is not generally thought as a separation technique. This is not considered as a separation technique. Rather, it is a purification technique in which we can have the small amount of the impurity can be removed from a compound. This is not removing the high amount of the impurity. We can go for first the crystallization, and then we should go for the recrystallization. It can be done after the crystallization only. So recrystallization works best when most of the impurities have already been removed. This is very important, that whenever most of the impurities are removed, we can perform this method. By the another method, it is more useful, like extraction and the chromatography. If we want to remove small quantity of the impurities, we can go for using recrystallization. So here you are able to see the recrystallization process. It is very easy. We have in a flask, we have a solute which is dissolved in the hot solvent, and then it is prepared as a saturated solution, and then it goes for cooling out. Okay, here it is go for cooling out, and when you go for cooling, if you have some liquid residue you can filter, and then finally you are having the pure crystals in your hand. A successful recrystallization always depends on the choice of the solvent. The compound must be soluble in the hot solvent. This is the condition, and should be insoluble in the cold solvent. The rate of the cooling, as we have understood before also, it determines the size and the quality of the crystals. The rapid cooling favors the small size crystals. If we go for rapid cooling, we have only small crystals, and if we go for slow cooling, it forms the larger crystals. Here you can see the growth of the large and generally pure crystals occurs when we go for the slow cooling rate. Now here what the term crystallization and the recrystallization sometimes used interchangeably, but technically it refers to the different process. We cannot say they are both the same. The crystallization is the separation as well as purification technique. It can be the separation like formation of the new insoluble, new product can be formed by any chemical reaction. You have seen in the reactive crystallization. There the reaction taking place and this produce a precipitate. So that's the new crystal which is formed by the reaction. So we can go for the crystallization, and it can be purified again by the same method, which if it is having many impurities, it can go for the crystallization. So recrystallization does not involve a chemical reaction. This is the main thing here, that recrystallization does not involve a chemical reaction. Crystallization involve a chemical reaction. That's why it's a separation technique, and recrystallization is a purification technique. It's simply dissolved in the solution, and the conditions are only physically changed and allowing the crystals to have the pure product. So I hope you are able to understand the crystallization method in detailing various types of the crystallization and how the crystallization process occurs, as well as the recrystallization method with the difference between both crystallization and the recrystallization. Thank you and take care.